Okay, I'm combining three sections of chapter 5 because really all three of these sections are talking about using um, somewhat complicated looking formulas and then substituting ratios into these formulas to find ratios for double angles, sum and differences of angles, half angles, and things like that. So they kind of all work the same. You can read through the book and how they are proving some of these formulas. But basically, I'm going to be focusing on using these formulas and really getting the idea that if you have a ratio, like for example, we know that cosine of 30 degrees, that its ratio, and I'm putting that in a box because if you were here in class, I would have you cut out little pieces of paper. And on one side of the paper, I'd have you write cosine 30, but on the other side, I'd have you write root 3 over 2. And that would really give you the idea that your function with its argument that and the argument being an angle, so that function with an angle is really the same as a ratio. And we wouldn't write cosine on a ratio. Cosine is a function telling me what to do for a relationship with that angle. And then we can use those ratios in these formulas to solve more complicated problems. If you look at the double angle formulas, there are three versions of the double angle cosine formula. So if it helps you, you pick the version that is the easiest to use for the information that was provided in the problem. And if you also look down below at the half angle formulas, that half angle for tangent, there are two versions of that. Personally, I like the first version better because it doesn't have a operation in the denominator. The half angle formulas for sine have a positive or a negative in front, so there is a choice on what you are going to choose for your angle. This choice is based on where a over 2 is located, on where the a over 2 angle is located. And by that I mean what quadrant. So if your quadrant 1, 2, 3, or 4, depending on that, that would, whoops, I need another line on that too. That would tell you. So, and for sine, if your half angle is located in quadrant 1 or 2, you're going to be positive. And for cosine, if your angle is in quadrant 1 or 4, you're going to be positive. So that is involving a choice. In this course, I will tell you where the half angle is located. You will know, but you do have to put the plus or minus in front accordingly. Okay, now if you were taking this as a test, we're not going to need to put these formulas on our wall because this exact page, I will give you a copy of this page whenever you're taking a mastery objective or a synthesis activity. Okay, so we're going to look at these angles and we're going to try to think about our special angles. And if it helps us to write angles as degrees, then we can certainly do that to help us think through these situations. So we have special angles and we have ratios for those. We have 0. I'm going to write them in degrees first, and then beneath it I'll write them in radians. So 0, 30, 45, 60, and 90. And then, of course, we do have, 180 and 270. I guess run out of room there. 270 right on the other side. And so if we were doing radian measures, we would have 0, pi over 6, pi over 4, pi over 3, pi over 2, pi, and 3 pi over 2. So we have those special angles. This particular angle being 5 pi over 12, if I want to find out what that is in degrees, so that maybe it'll be a little clearer how to do the decision on this, that is 75 degrees. So based on our choices up above, and based on what we're doing, sum and difference, half angles, double angles, I can think about what possibilities I might be able to do with those things. If I'm thinking sum, I would look up above and say, are there two numbers from above that when I add them, I will get 75? And yes, 30 plus 45 degrees will be 75. If I wanted to look at the double angles or the half angles, I could have thought of my angle, think of my angle as a 75 times 2 would be 150, and 75 divided by 2 would be 37.5 degrees. So the half angle formula would be a possibility for doing. I know this looks like it would be the double angle, but if you think about it, if I used the angle of 150, if I could use that, then I could find the 150 over 2. So I could have done this with a half angle formula as well, but definitely the sum formula, which is what I wanted to use for this page, the sum formula is going to be the easiest version to use for 75. So let's just pretend that this thing was 75 degrees. And so you're going to get points just for writing down the formula from the formula sheet. We decided that we thought if we could take the 30 and add it to the 40, that would work. So we are doing an A plus B formula. So when I look at the front page, I am going to find my A plus B formula. Let me just write this. I'm going to write the formula and then I'll write the 75 underneath. So the formula from the formula sheet I see is cosine A plus B. And then I'm going to write it exactly as it's shown on the formula sheet. I have cosine A, cosine B, minus sine A, sine B. So I write it exactly as I see it on the formula sheet. That's part of the work, part of my points. Cosine 30 plus 45, it doesn't really matter which order. So what I've decided is that A is 30 and B is 45. So the next step of my work is writing the trig functions with the appropriate angles in the spots because I'm working with angles. There will be times when you don't have to write this step because you will go right to the ratio. So you wouldn't have a trig function on it. Now that I know this, I can say that the cosine of 75 degrees will be, I need the actual ratio for a cosine 30. The actual ratio is root 3 over 2. It's not cosine root 3 over 2. It is root 3 over 2. And if you were here with me, I would have you write on little pieces of paper cosine 30 on one side, its ratio on the other side. I'd have you write cosine 45 on one side of a piece of paper, and on the other side, you would have written root 2 over 2. Sine, you would have written a half, not sine of a half, just half, and sine 45. And now we're going to have to simplify this. So we know that cosine 5 pi over 12, which is the same as 75, will be root 6 over 4 minus root 2 over 4. You cannot simplify any of this. The root 6 is protected from the 4, and the root 2 is not a like term. The back of the book may have combined these things with a common denominator because they both have a 4, and if that were the case, it would have been written as root 6 minus root 2 all over 4. So both of those are appropriate, and of course the order can be changed, but the negative does belong in front of the root 2. Okay, so now let's recap. We're looking at this. We see a plus sign in a cosine formula. So I need to identify what formula I think that is the closest to from the formula sheet. And so I will write that formula down. That will be part of my points. And it happens to be the exact same formula that we just wrote. Okay, now we're going to put in the variables that in their locations so that I'm going to be able to identify what variables. Putting everywhere where A was, I will put an X. Everywhere where there was a B, I will put a 2 pi. Whoops, I forgot to write the, that's supposed to be an X. Okay. Now I'm going to continue my simplifying. I cannot combine any like terms in this situation, but cosine X. Cosine of 2 pi, if I think about what that would be as a ratio, 2 pi, cosine of 2 pi would be the same as cosine of 0. And the cosine of 0 radians or 0 degrees will be 1. So I'm going to put a 1 everywhere where I saw cosine 2 pi. And then sine x. And now I need to know what the sine of 0 degrees, and that is 0. So it's very helpful to have a table of these values. When I see a product that is 0, I like to cross it off to make sure that I know that sine x times 0 will be 0. So I have just proved that cosine x minus 2 pi, I have just proven that it really is cosine x. And this process works in the other direction too. If you have something that looks rather complicated, but it's corresponding to one of the formulas from the front page, we're going to write that formula exactly as we see it, and then we're going to examine for how we're going to put things, condense them, and make them simpler looking. For example, if you have something very complicated like this, just to give an example of a minus 1, and it's all over 3, then that could be condensed down to 7 minus 1, 6 over 3, which equals 2. But like somebody could still go the other direction too. So we're going to be able to make things simpler or make things more complicated if we need that process. So I'm going to write down this formula from the formula sheet. It happens to be the exact same one that you were using the other 2 times. Whoops, cosine B. Let me just sine A, sine B. Okay, so now what would A be? I can see that A is 3x. So cosine of 3x plus 2x will be equal to, and if you want to rewrite the original formula, you can. It is already written right here, so I'm not super concerned with it. As long as you've written the formula that you're using as your work, I will write it out though, just to show you how this would have been the expanded version according to that formula. Okay, so now what students do a lot is they'll forget to simplify. Don't forget to simplify, because what's in the parentheses are like terms. So there's a cosine, and what's 3x? 3x plus 2x. If it was outside of that function, you would say, well, that's 5x. So let's do that. Let's say it is cosine of 5x. Parentheses not totally essential there. Last one. Might be helpful to find out what a pi over 12 is in degree measure, just to be able to know that it is actually 15 degrees. How to make 15 degrees using sum and difference formulas, I would suggest, well, you have 2 choices. You could either do 60 minus 45, which is usually not the one people see. Most people see 45 degrees minus 30 degrees. These, in this situation, there's not one that's better than the other. However, in the tangent situation, if it's a tangent situation, it's definitely better to use the 60 and 45, because tangent of 60 degrees is a nice root 3, and tangent of 30 degrees is the much more complicated root 3 over 3. So if you have a choice between a 60 and a 30, especially in consideration of the tangent, you would want to go with the 60. So let's write our formula. It looks like we have a minus situation. We have a sine function, so it's going to be the sine minus the difference. Minus, let's see. Yes, on the minus formula, it's a minus cosine A sine B. Okay, so there's that. And then I don't know which one you've decided to use, but I think I'll go with the 60 minus 45. So sine of 60 degrees minus 45 degrees. And that would be putting everywhere where there was an A, I will put a 60 degrees. Everywhere where there is a B, I will put a 45 degrees. And I'm going through and writing all of those. And now, if you were here in class, I would have you take out your cards, and you would know that sine 60, and you'd be able to turn it over, And on the other side, you would have a ratio. And on the other side of that 60 card would be root 3 over 2. And root 2 over 2, not with the cosine on it. So in our situation, we were working with pi over 12, and we get root 6 over 4 minus root 2 over 4. You'll see that these numbers show up in all of the sine and cosine sums and differences using 30, 60, and 45. So, or the back of the book may have written this as a root 6 minus root 2 all over 4. Now, if I was to think of this 15 degrees as a half angle, if I was to think about this using a half angle formula, this last one, I'm just going to say, if I wanted the sine of 15, the sine of 15 degrees, which is sine half of a 30 degree. Okay, so if I have realized that I could use this version, then I would then write down the formula for a half angle formula. So that would be sine of a over 2 equals. Now you have to make a choice. And where would 15 degrees be in a Cartesian coordinate system? It would be in quadrant 1, meaning I'm going to have a positive, and I will tell you what quadrant you're in. And then you would have the formula 1 minus cosine of a over 2. So I have my formula, and now I want to go through and I want to do this with my 30 degrees over 2, because that's a 15. 1 minus cosine of 30 degrees over 2. And now the difficulty with this formula is you have to simplify everything under the radical before working with the radical. So I know that my sine of 15 degrees will be, let's find out what I have under my radical, 1 minus, and it's root 3 over 2, all divided by 2. Fractions can be difficult to simplify. I think in this situation, the easier way to simplify this is to start off by maybe sending that 2 to each term, and then we'll try to add our fractions afterwards. So I'm going to move over to the left and start doing that. So I've got 1/2 minus, notice how I'm trying to keep my square root over everything. So far I've done that. Now I'd like to try to get my fractions to be one fraction, keeping my square root very big, and I need to have a common denominator, so I'm going to use 2 and 2 on this one. I don't need to modify the other one because of the 4 already being there. And now I will take the square root of each piece. So the numerator, 2 minus root 3, nothing can be done to that very complicated looking thing. But I can, breaking this apart, take the square root of 4. So square root of 2 minus root 3 over 2. That is equivalent to the answer that we found previously. If you punch them in successfully in your calculator, you will see that those two things are actually the same decimal answer. So a person could express this answer in 2 different ways and it would have been fine. And so 2 different approaches to find it. This one looking very different, but being exactly the same value as that one right there. And you cannot simplify either of those any further than what I have done. Here's where we'll never actually know what the angles are. We could find them by using our inverse trig functions, but we're not going to bother finding them. We're just going to use the ratios that are available. And this is another place where I would have you make cards of your ratios with your functions on one side and your ratios on the other. Based on this piece of information, I have told you everything you need to know to come up with all the ratios for sine of A, or for angle A. So based on that information right there, I'll write it at the top, that we know that A is in quadrant 1. We know that sine A is 3 over 5. And if you had cards, I would have you write on one side sine A, and on the other side 3/5. But we could also find cosine of A, because we know that 3 squared plus x squared will equal 5 squared. And after solving that, x is equal to 4. 4 over 5. It's positive because I'm in quadrant 1. Tangent A. 3 over 4. So that's all the information that I have for A. Now I can do B, which is in quadrant 3. So angle B in quadrant 3. And I know that cosine of B is equal to negative 5 over 13. Sine of B, after using my 5 squared, and it actually is a negative 5, but negative 5 squared plus y squared equals 13 squared, you would find that y was equal to 12. But technically, that is a negative 12 because you are in quadrant 3. So sine B is negative 12 over 13. And tangent B is 12 over 5, and that one's positive because you're in quadrant 3. So let's start by writing our formula. We know exactly which formula they want us to write. It's the sine A plus B formula. Cosine A, sine of B. Okay, now here's where do not write the numbers in any, this would be totally wrong. Writing this, 3/5 plus, who knows what people would write, but you just don't write those numbers in that. That is completely wrong to write any number in any of the A's or B's. It is completely wrong to do that. So don't write your ratios like that. And that's why I have if you were here, I would have you write on one side of your paper, I would have you write the sine of A, and on the other side, I would have you write its ratio of 3/5. So that being said, on the other side of your sine of A card, you would have a 3/5. And on the other side of cosine B, its ratio is negative 5/13. On the other side of cosine A is 4/5. And the other side of sine B is negative 12/13. Imagine those little cards in your hands. Okay, let's see. This is 15 over 65 plus a negative, 48 over 65. That becomes negative 63 over 65. What's interesting about this is that this actually will be all the information for all the info for an angle that's the size A plus B. we would know that the y for the a plus b would be negative 63, since this is a sine. The r for the a plus b would be 65, and I could do the x squared plus y squared equals r squared. I could find my x for this, and I could write my ratios for this a plus b angle. I could write all the ratios. Cosine a minus b. So off the formula sheet. Try this problem on your own. Look at your ratios, try it on your own, then look at what I've written, look at what you write, see if there are any differences. Make sure you are not writing cosine on any ratios. Then I would solve and simplify what this is equal to. And I get negative 56 over 65. And again, that would be, because it's a cosine, that would be the x for an a minus b angle. This would be all the info for an a minus b, that angle. That would be all the information for it. You could write other ratios as well. Now the tangent. So tangent a plus b, parentheses, equals tangent a plus tangent b over 1 minus tangent a tangent b. Okay, we saw that tangent a was 3/4, so we'll put that in. Tangent b was positive 12/5. I'm putting that in. This is going to require some work at fractions. My recommendation is to use the math fractions, but first to find out what the numerator would be as a fraction, and I get 63 out of 20, and I would find out what the denominator is as a fraction. 1 minus this fraction of 36/20, so 1 minus that would be negative 16/20, and then to look for things that cancel, or put parentheses around it and have your calculator do it. Parentheses are essential in this case. Math fraction, and you get negative 63 over 16. The negative can float around like that. And if you were thinking about it without a calculator, you could think about how when you're dividing by a fraction, you multiply by its reciprocal. So it makes it a little more obvious how those 20s canceled away. And always make sure that you have actually reduced the fraction to the lowest terms. Now we're going to throw in some half angles and double angles. So especially with the double angle on the cosine, you get to pick what you want to use. And you're going to have to make sure that you're using the correct ratios that they specified. Like this one is dealing with B and not A. And I actually did change the ratios a smidge here. So I've got cosine A is 3/5, sine of A is 4/5, tangent of A is 4/3. And that was for a quadrant 1 angle with an x of 3 and an r of 5. So now I've got a quadrant 3 angle, and I've got sine of B equals negative 5/13. Cosine of B, maybe I didn't change them. I'm in quadrant 3, so I am negative 12/13. And last one, tangent of B, and I've got, it's going to be positive because I am in quadrant 3, and 5/12. So those are my ratios. I have all the information I need in order to do this problem. So which one would I like to use? I think if I was picking, I would stick with the probably the third form of cosine 2a, because, and that formula would actually be using b, because even though the formula says a in it, I would want to be using the b. So I will write down the version that I'm going to write down with the a, but just to show you. But I think what I would skip this step personally is I would skip this step of writing 1 minus 2 sine. It doesn't matter which one you use. Now notice that you are actually using b, so the correct version of the formula should have been this. And now I look at my ratios, and 1 minus 2, and whatever sine b is, negative 5/13. Very important that you have those parentheses to tell your calculator that you're really squaring something. And it is going to, if you punch that in correctly and you hit math fraction, 119/169. And now I know what the x value is for an angle of 2b size, and I know what the r is for an angle of 2b size. Let's write the formula. I would tell you that the half angle is in, that's going to be in quadrant 2. I would have told you that on a test situation, but I just want to show you that, like in this situation, knowing the angle B is in quadrant 3, it's somewhere between a 270 and a 180. So a half B, how would someone figure this out? A half B would be somewhere between a 90, because that's half of 180, and a 135. So 135, maybe somewhere like that. So the half angle would be somewhere between 90, because that's half of 180, and 135, because that's half of 270. So this angle squarely in this area, I would have told you it was quadrant 2, but it can be determined by using a little bit of thinking it through. So this time I'm just going to write the formula without the a. I'm just going to go right to the b and write the formula. So I know that cosine in quadrant 2 would be negative. And now I'm writing my formula. And notice I substituted the b for a because I know that I'm going to be working with ratio of b. And now down here, I'm going to just start working this through. Make sure your square root looks like it's covering everything. Make sure this goes down enough so it looks like it's covering the whole thing, because it's supposed to. Now remember what I said about simplifying. Probably the easiest way, forgot my negative. Easiest way is to break those fractions apart first. 12/26. Break those fractions apart first. And then once I've done that, I will get a common denominator if I can. Looks like it. So I end up with 13 minus 12/26. All of it's under the square root. All of it needs a minus in front. Okay, continuing, negative. Let's do the square root. 1 over 26. So simplify that. Negative square root of 1 over the square root of 26. Rationalize. Negative root 26 over 26. The book may have left it as an unrationalized 1 over root 26, but we're going to try to rationalize. And now I've written all the way into my tangent area, but, well, that's annoying. Try to write smaller this time. I'll write in green. Okay, tangent A, that's right on the formula sheet. 1 minus cosine of A over sine of A. Let's get our formulas, our ratios. 1 minus 3/5. If you like parentheses around it, that's helpful. 4/5. Now we got to figure out, I like to find the numerator, 2/5 over 4/5. I see some canceling, dividing by the reciprocal, or dividing by a fraction, multiplying by the reciprocal, but I do see some canceling. I'm now 2/4, and it comes to be a half. So there's my answer to that one. And I'm just going to put a little line on this that makes it clear that this is for that other problem. Okay, well, at least I have a little more room now. Pause the videos, try one yourself. 2 sine A cosine A equals 2 times 4/5, 3/5. Don't forget the 2 is up with the 4 and the 3, so my product is 24 over 25. Tangent to A from the formula sheet. 2 tangent A over 1 minus tangent squared A. I'll continue writing this direction. 2 times 4/3. Remember that the 2 is up with the 4. Minus 4/3 quantity squared. The 2 is up with the 4, making it 8, a product of 8 over 3. The 4/3, 1 minus 16/9. 1 minus 16/9 is negative 7/9. So maybe this is a situation where it's helpful to use that multiplying by the reciprocal, and I get my 8/3 times negative 9/7. Now watch for canceling. Also, you can use your calculator with parentheses, very important, around your fractions. If you're going to have the calculator do this, and I get negative 24 over 7. Last one on this page. Again, I would have to have told you where the angle was, but knowing that angle A was in quadrant 1, half of angle A would most definitely be in quadrant 1 as well. So half of angle A would have also been in quadrant 1. We're going to need a positive on our function. Okay, so positive, I don't really need to write, plus, oh, that's supposed to be a minus sign. I guess I was thinking plus minus, but, or minus, but minus 3/5, that's a 1 over 2. I don't like the way my square root is too short. I'm going to bring it down. Bring yours down. Look at your square root. Make sure your notation looks good. And then now I'm going to break that apart to, oops, let me break that apart into my two fractions. 1/2 minus 3/10. That's what that does, becomes 3/10. Now I need to combine using my least common denominator, which is going to basically be 5/10 minus 3/10, because I would have multiplied that first one by 5 over 5. So I get 2 over 10 and square root. But can we reduce 2 over 10? Can we? Yes. It is the square root of 1 over 5, 1 over root 5, which rationalized is root 5 over 5. So that one is rationalized. Now, on the last page, we'll do some trying to identify what formula you have from the front. And I know the textbook kind of does it a little differently, but all I'm asking for you to do is try to identify what formula it is and see if you can simplify things successfully on the last page. So here are some very complicated looking things, but we know that the conjugate, well, actually this first one, I can't see this one on the sheet at all. So we're going to have to go through and just see what we can do with it. It's an example where the conjugate would not have helped us though, but we can see that there is a similarity to this version of the identity. So we can see that identity somewhat in what we see, that we have a 3x. So knowing that that really is just going to mean that we're going to have the cosecant with the 3x. So I am going to rewrite this over cosecant squared 3x. Now what I'm going to do is I'm going to write things as sines and cosines. I am going to keep my 2 where it was. The cotangent is a cosine 3x over a sine 3x. That's the cotangent. Now the cosecant needs to come up as a sine squared 3x. So I have just brought that up. Look at every stage of the game, you look for canceling. So we are looking at a formula that looks like 2 cosine 3x sine 3x. On the formula sheet that you received today, that looks a lot like a sine 2a. The order is different, but the result is the same. So I would say that if I am looking at a 2, and I'm just going to change the order, but I'm going to write 3x and cosine 3x. If a is 3x, when I am writing my version, I need to put a into the places there. And so this is sine of 6x. So this whole thing would be sine of 6x. All these pieces, the 2, the sine with the angle, the cosine with the angle, all combine together to make a sine of 6x. And what the analogy that I use for this to maybe make you think of this is if you're baking a cake and you've got your eggs and you've got your water and you've got your mix, your box of mix, and you mix it together, in the end, you're going to end up with a cake, maybe a birthday cake. That's fun. And so all those ingredients, when you look at your cake, do you see your eggs? Do you see your water? Do you see your mix that went into the cake? You don't see these things. You see a cake. And so all these ingredients, if they are combined in the correct way, you're going to get a cake, a sine 6x. So don't double this 6x. Don't put a 2 in front of it, because that 2, that was like the water. That had to be there to combine to make that final product. So let's see what this one looks like. So the next formula, if you look on the formula sheet, it looks a lot like the last one. And it's the first version of the half angle tangent formula. So if I write down that half angle tangent whoops, gotta write tangent. Tangent a over 2 is equal to 1 minus cosine of a over sine of a. And so I look at this and say to yourself, what is a? What is a? What all these ingredients put together in this manner, in this format, all these ingredients will put it into a tangent cake. And that would be like that. So I'm going to take my a is 8x. What would a over 2 be? 8x over 2, 4x. So tangent of 8x over 2 will be tangent 4x. Last one for this package, and this says once you've simplified it, find the exact, let's find the exact ratio. So this formula with the ingredients going in, with a 2 in the front, with a tangent, with a 1 and a minus, and a tangent squared, all those ingredients going in, reminds me a lot of the tangent to a cake. And so everywhere I see an A, I'm going to want a 15. So everywhere I see an A, I will want 15 degrees. A 2A will be 30 degrees. So let's take our cake here, and tangent of 2 times 15, which if you wanted to just write tangent 30, I don't mind, that is tangent of 30 degrees. And then they said, well, why don't you give us the exact ratio? And for 30 degrees, which is in quadrant 1, so positive, and the ratio for a tangent, if you have to draw the triangle for 30 degrees, 1 root 3, there's my right angle, and it's opposite over adjacent, 1 over root 3, but rationalize. Hopefully you have a table of these values and you could just get that value.